We've talked about confidence intervals for slope. Now we get to talk about tests of significance for slope. So the first thing I'll do is do a quick Fathom demo as to really what I mean. Here's a demonstration that I've made to talk about the test for significance for slope. I've set up x and y here to be random, right? So you can see the random function. X's are being randomly chosen between 10 and 40, and Y's are being randomly chosen between 10 and 40. There's no function that relates Y to X. Y is not a function of X. So really, there should be no association, no correlation between these two. But notice that because of random variation, if I wanted to make a line of regression, of course I could, right? It's got a pretty low coefficient determination, only 0.17. But if I were to re-randomize, right, notice that this, man, the correlation or coefficient determination is nearly 0. But then at other times, that's a great example, all of a sudden it goes up to 0.25, which is still kind of low. But if we get a data set like this, how do we know whether this slope is due to a real association or due to random chance? Because as you keep randomizing, right, there are times, and here we have a negative slope, right? So this is going to be the test of significance. Right? If it's still low, right, is it significantly different than 0? Now what we're going to do is a specific example. So here's some data. Right? I don't have any context for this. It's just sort of x and y. Here's the scatter plot. And really the question is there convincing evidence that there is an association between the x variable and the y variable? So we're going to go through 4 steps. Right? First step, right, conditions for inference. You know, is it okay for us to do inference in this specific case? So we're going to need our residual plot. So I made that. Here's our liner. Right. Does it appear to be linear? Yep, it certainly appears to be linear. Independent. This is a proceed with caution because we aren't given context. We don't know whether the population is bigger than 110. In this case, n is 11. There are 11 numbers. But since we have no idea what this context is, we don't know if there are 110 of these things. And we just need to note that the 10% rule does need to be met for inference to be okay. We have the normal. This is approximately random or rectangular, equal standard deviations. There's about as much above the 0 line as there is below the 0 line. Again, random, we aren't given the sampling method, so it's a proceed with caution. Inference is only possible when a well-designed randomization is used. So we have 3 confirms, 2 proceeds with cautions, nothing has declined. So we have met our conditions for inference. Now we get to hypotheses. For test of significance for slope, right, we start off our null hypothesis is that there's no association, which means the slope of our true regression line should be 0. Now the alternate is that there is an association, which means it's not 0. In this case, there's actually a negative slope. Right? It would be true if it was positive as well. Now we need to get our p-value. Right? This is where all the calculations come in. So what we're going to need is to get our spread, which is what we did for confidence intervals. So I know I'm going to need my spread of x's. Right? So that's 9.03. I'm also going to need the spread for residuals, which means I need the linear regression line. So I use my InfLinReg and I store it into y1. Right? And that gets me my sample slope as well, just negative 0.602. I'm going to need to calculate those squared residuals, right, which I've just done in L3. I've added them up. And of course, now I can actually calculate what the spread of the residuals is. Once I've done that, then I can actually start calculating my standard error. I can plug the numbers in, and my standard error for sample slopes is 0.224, which means I can now start drawing my sampling distribution for sample slopes. It's a t-distribution. It's always a t-distribution centered around 0 because that's my null hypothesis. And I can now dimension out to both sides using my standard error. And now I can plug in what the actual slope is. And of course, I'm doing this as a two-tail because if there is no association, the fact that this is negative is equally likely that it could have been positive. And so it's pretty much always a two-tail test for tests of significance for slope. So I need to find the area of these two tails, add them together, and then that's going to be my p-value. To do that, of course, I'm going to need, first of all, my degree of freedom, because it's a t-distribution. Remember, it's n minus 2 for the degree of freedom for two variable. Then I'm going to need my t-statistic, right? How many standard deviations is 0.602 away from the center? It's going to be a little over 2.5, 2.7 almost, right, is our t-statistic. Then what I'm doing is calculating the t-CDF is this tail, right? My lower bound is negative 1,000, t-scores, which is way over to the left. This is my upper bound, because that's this boundary right here. And my degree of freedom is 9. There are two tails, so I multiply times 2, and I get my p-value of 0.025. Once I have my p-value, I can do my interpretation, which is to say that since 0.025 is less than 5%, I reject the null hypothesis. Therefore, I conclude that there is an association, because, of course, the null hypothesis is that there's no association. I've rejected that. So I'm saying that there is an association between the x variable and the y variable. Now, unfortunately, that turns out to be wrong. Why is that wrong? Because something I didn't tell you, that this data actually came from the same simulation in Fathom that I used in that demonstration in the beginning of this video. So these are random numbers, right? There is no association between x and y. So what's going on here? Well, this is a type 1 error, right? We rejected when we shouldn't have rejected. That's going to happen about 5% of the time. So we're just in a type 1 error situation. Now, let's see how we use the TID4 to do tests of significance. So here's my data in L1, L2. All right, let's go back to stat and tests. And near the bottom is our two InfLinReg tests. This is the t interval, which we used for the interval, confidence interval. So what we're going to do is do the InfLinReg t test. All right, I've plugged in L1 and L2. Again, frequency is 0. Right, this is two-tail. So really, this is all set up. This row, this is a Greek letter rho, which is the Greek letter R. Notice that we're talking about association, so this is really highly related to correlation. And so the sample correlation is R. The true population correlation is rho. And so really we use these somewhat interchangeably. If there's 0 for the slope, that means there's no correlation. But let's go down to calculate. And here we get our p-value of 0.025, just like what we did before. It gives you the t-statistic. The conclusion is that the population slope is different than 0, right? Is not equal to 0. It shows you a bunch of other statistics, which is convenient, but really this gives you your p-value where you can draw your conclusion. And unfortunately, again, we're in a type 1 error situation here, but 95% of the time, that won't happen.